Hi there, I'm Tom Field. I'm Senior Vice President of Editorial with Information Security Media Group. Thrilled to welcome you to our session today entitled Managing Risk Where Hardware and DevOps Converge. Your speakers today include Bob Aiello, DevOps Architect with CM Best Practices Consulting, Steve Venema, Distinguished Engineer with ForgeRock, and your moderator, whom I'll turn this over to, Altaz Villani, Research Director with Security Compass. Before we turn this over to Altaz and the team, let me give you a little bit of background on what they're going to talk about here today. Today, we can no longer restrict our software security risk assessments to cloud and mobile profiles. With more hardware devices being integrated, we have to extend the software layer to also include firmware. That implies the convergence of traditional software above the kernel and firmware below the kernel development processes. The good news, there's much that's common to both domains. However, in a DevOps world, we need to consider how automation across these teams can enable the business to keep moving fast. In this session today, our team will discuss how to successfully integrate firmware and software security into a system delivery model that produces secure systems and products. A little bit about my organization, Information Security Media Group. We're a global education and intelligence firm. We're based in Princeton, New Jersey. You might know us by one or more of our 30-plus media sites. These include Bank Info Security, Gov Info Security, and Data Breach Today. In all, we've got more than 30 of these sites around the world. We reach an audience of 950,000 security leaders for whom we're producing news, analysis, and education on a 24/7 basis. Now, just a few notes of housekeeping. If you have any questions for our panel today, please submit them anytime via the question window on your screen. We won't be able to get to every question, but for those that we can't answer today, we will get responses back to you via email. If you have any technical issues while viewing today's webinar, please dial the number you see on your screen. We do have technical support staff standing by to help. And I do need to remind you that today's webinar is copyrighted material. It's meant for today's session and individual study purposes only. If you'd like to use any of the information presented today, then please contact us independently. Really my pleasure to introduce our sponsor today, Security Compass. Security Compass understands the importance of security and speed to market in your business. That's why they've developed the industry's first balanced development automation platform, SD Elements, to drive fast and secure application development. Security Compass also offers advisory services on emerging technologies such as cloud computing to strengthen your security posture. The world's leading financial organizations, technology enablers, and renowned global brands trust Security Compass to secure their applications. Now, let's meet our speakers today. You're going to be hearing from Bob Aiello. He's a DevOps architect, trainer, and coach. He's got decades of experience leading enterprise software process improvement initiatives. He's written several books, co-authored the IEEE industry standard for configuration management, and most recently led an international team writing the industry standard for using DevOps in highly regulated environments. Steve Venema will be joining us. He earned his master and PhD degrees in electrical engineering at the University of Washington in the 1990s, with a focus on networked control systems and robotics. He subsequently spent 16 years at Boeing, developing technologies for manufacturing and aviation systems security. Today, he is a distinguished engineer with ForgeRock. And it is my pleasure to introduce Altaz Villani. He's the research director at Security Compass. He's responsible for managing the overall research vision and team. Prior to joining the group, he was a senior research director at Infotech Research Group, providing CIOs, IT managers, directors, and senior managers with trusted advice and analysis. And with that, I'm going to turn this over now to Altaz to lead our discussion today. Altaz, the stage is yours.
Great. Thank you very much, Tom. I appreciate it. What I'm going to do real quick is I'm going to share my screen and let's get a whiteboard up. Folks, this is going to be a highly interactive session, so feel free if you've got any questions, any comments as we go through this. It will be an opportunity for us to dialogue together and so that we have the opportunity to kind of make this dynamic. So kicking this off, before I kind of move forward, can everybody see the whiteboard screen here? Are we okay?
No, I don't think so. That's better.
Okay. There we go. There we got it. So we're going to be talking about managing risk where hardware and DevOps converge. And, Bob, I mean, you've chaired the group that developed this whole DevOps standard. There may be various degrees within the audience in terms of their understanding of DevOps. Could you give us just some highlights, some key things around DevOps? And then I'll turn it over to Steve to provide some thoughts around hardware. And I'd like the two of you to focus not just on what are the different stages of either DevOps or the hardware lifecycle, hardware development lifecycle, but focus on the security aspects as well. So Bob, first to you, please.
Sure. So we've spent many hours debating what DevOps really means, and how it began in 2009 at some smart people conferences. The best definition I've come up with is a set of principles and practices intended to help different stakeholders communicate and collaborate more effectively. Now, the most classic one that we talk about is developers who want to go fast and operations that wants things to be nice and stable and secure. And we often focus a lot on deployment automation. But the essence of DevOps is that you're looking at things from different perspectives. And that is so perfect for today's discussion, because hardware engineers often think of things in a particular life cycle. When I've tried to teach iterative development of hardware engineers, they've said to me, hey, Bob, half a circuit chip's not going to do much for me. I have to take 3 months to fabricate the whole chip. And so hardware engineers often look at things in one way, and their colleagues who write the firmware, and many hardware engineers also dabble in firmware, but the folks who write firmware, software, and cloud-based development, they work in a very different way. So this is a perfect DevOps scenario where our job is to bring these different perspectives together, accelerate velocity while ensuring secure and reliable systems.
Wonderful. That sounds good. And I'd like to hand it over to you, Steve, if you can give just a quick highlight from your perspective. You've done a lot of stuff on the hardware side as well. What insights could you give just to kind of make sure we're level set here?
Yeah, I think, in an oversimplified sense, firmware is just software that is harder to change, right? Mm-hmm. In terms, so the life cycle is different, and that gets down to the hardware as well. As Bob mentioned, the chips have a long life cycle. If you're making a chip, then you may have months before you get something out of fab. Countervailing trends there are twofold. One is the more configurable chips. I'm trying to think of the name of them right now. The FPGAs, for example, field programmable gate arrays. So you'll see those oftentimes used in prototyping, at least, because you can get the fast reconfiguration if you don't have something right. And eventually, if you want to go to volume, then you may get custom silicon. At the firmware level, development without the hardware can be somewhat challenging. You typically will see simulators being used, but the fidelity of that is sometimes questionable. Depending on the application domain, firmware may be talking to things that are not all ones and zeros. It may be analog data and therefore noisy and subject to various kinds of crosstalk and errors that aren't typically thought about from somebody who's writing code and expects the for loop to work the same each time, kind of thing. So those are just some of the highlights, anyways.
Yeah, that's interesting. Go ahead, Bob.
So an interesting aspect of that is that the hardware obviously is fabricated, and you could create a new rev of the hardware, but the firmware that runs on the hardware could conceivably be changed unless you're doing something where you can only flash once for security reasons. People do that. But let's say it's a medical IoT device, and you can uprev the firmware on that device. That may be talking to some software on a cloud-based server. So you really have the perfect trilogy of the hardware, which may change over time, the firmware that runs on the hardware, and communicating to software-based resources. And that's a lot of change to manage. And right now, this is one of the areas that's getting very, very challenging because our traditional approaches of taking a waterfall life cycle to hardware are not going to necessarily meet our needs to accelerate delivery going forward. So it's a true DevOps challenge, and it's one of the reasons why it's so exciting. And I've really been enjoying working with different stakeholders on this particular issue.
Yeah, it's interesting. Sorry, go ahead. Steve, you had a comment you wanted to make on that?
Just that firmware may have different meanings to different people. On a platform that has may have firmware talking to hardware and then a kernel and then an application running on it. That's one thing. In a device that is deployed as a unit, say an IoT device, often firmware is considered the whole shebang, everything I mentioned. So I think we have to be a little careful with our nomenclature. Typically for an IoT device, you update everything, but for say a phone, of course, you can deploy an app separate from updating, say, the operating system on the device. So.
Yeah, it does get complicated, and it all comes down to the bill of materials, right? We manage the hardware specs as well as the firmware when it's a child to a hardware device. So the bill of materials, the BOM, which is not something that most software developers worry about too often. They may think about a Maven manifest, but the BOM is really the area where I'm focusing on how do we bridge the gap between the folks who are developing the hardware and the different types of firmware, as you aptly pointed out.
Right. Go ahead, Alphonse.
So I was just going to say, now we're starting to get into an area of how do we operationalize some of this stuff, and I'd like to dig a little bit deeper. Bob, you opened up the conversation around bill of materials, so we hear a lot about BOM, SBOM, stuff like that. When we talk about the supply chain and the integration of DevOps across the supply chain, how can we in fact ensure security? It's a hot topic right now. So Bob, just can you introduce this idea of a bill of materials? Sure. Some thoughts around what goes into this bill of materials. Can you talk about this? And then I'd like to flip over and I'd like to get Steve's perspective on a bill of materials as it pertains to the hardware and the firmware side too.
Yeah. So on your board, could you put the BOM and give me a parent, a part number, and then make a child part number? And I'm going to speak to that example. It's a really exciting example. And let me tell you that when the pandemic started, I volunteered with a team to create ventilators. And we wanted to open source ventilators. And as a team, we all wanted to be able to create thousands of ventilators really fast. And of course, ventilators are in the regulatory space. We had to think about how do we stay clean in terms of regulatory compliance, but really weigh the anchor and develop these ventilators fast, because the faster we came up with them, the more lives could be saved. Now, the good news is we weren't needed. It turned out that we had enough ventilators, but we faced this very real problem of how do we use agile principles and velocity in DevOps to create ventilators at a point when we thought we might need hundreds of thousands of them. So in looking at the BOM, the bill of material, you might have a parent part number that could be a piece of hardware, and running on that hardware could be some firmware. So I would make the child item a child of that topmost assembly. And Steve, I'm sure you've got different examples. I'm going to come up with a simple one to get the point across. The child, being the firmware, could iterate many times. You might update that firmware for any number of reasons. It's usually major, minor bug fix, right? So the patches, the bug fix, you could have quite a few of those. You might even have some minor changes. And that's not necessarily changing the form, fit, or function of the parent piece of hardware that the firmware is running on. So we don't want to keep changing, or what the hardware guys call up-revving the parent every time we change a little bit, a patch in the firmware. So we have this very interesting example. Software developers are used to iterating through complex software that has a very large set of dependencies. But this kind of a problem that I presented to some hardware engineers, they're not used to the notion things could be changing in the firmware without affecting the parent. And in the example that I brought, if I wanted to create ventilators in the hundreds of thousands, we had to think about how could we accelerate velocity? Because doing things in the old software development lifecycle could actually cost us lives. So we had to think about, how do we get innovative? How do we still stay compliant, but actually get a little more agile and really use true DevOps principles? Steve, what do you think?
Well, I can draw in a different, I guess I would call it a corner case example, which is in the aviation space. Airplanes run software as well as hardware, right? And the way that the aviation domain has dealt with this is they treat, just like certified parts, could they be bolts or wings or flaps or whatever, software is considered a part as well. And the deployment, the management and deployment of those software components are treated as installation of parts. That's gotten more mature over the years. I mean, I think a 747 probably still loads software with floppy disks, versus, say, a modern airplane from Airbus or Boeing might do it wirelessly. But there's a whole chain of custody, integrity concerns about the software, audit concerns, and so on that I think the aviation industry kind of highlights it, although velocity is not their first priority. It's safety. There's different levels of software assurance. If it's a critical system, that goes through say a more rigorous task than, say, a cabin entertainment system used to drive the video on your seat back. Just as an example.
But now there you went. You went and did it. You gave me a choice between safety and velocity, and I'm going to challenge you because I brought you a use case where I needed both. If I focused on safety with those ventilators, and I didn't deliver a few 100,000 ventilators to save people's lives, then what's my safety doing for me? So part of the challenge that I see, and I think it's a real challenge, is that we need to be able to adhere to regulatory compliance at all times, maximize security. We don't want grandpa's pacemaker being hacked, but at the same time, looking for ways to enhance our velocity and our agility. And the question I have for you, Steve, is, am I going to up-rev the plane software if I simply change a toilet somewhere on the plane? So sometimes child changes are not really relevant to the rest of the assembly, and they are considered minor.
Right. Yeah. I imagine there might be a little bit of software in a toilet. I don't know for sure. On a lavatory and an airplane, I know they're kind of modular. Certainly, there are hard dependencies and software dependencies. I think, I think the part of velocity that I'm thinking about is really about what risks you're going to tolerate and which you're not. I mean, I think if you take the ventilator example, you may have, let's say you find a bug that's causing issues in the use of these, then the speed at which you deploy that is really critical. The deployment of something to the market is a different kind of velocity, also important. Particularly for maybe not, well, certainly for the ventilators, but different products have different time cycles or time constants. I don't think it's either or, velocity or security, but I do think you sometimes have to make trades in that space, and that has to do with evaluating.
And I like what you're doing with that. Because there's always a risk of making a change and a risk of not making a change.
Yes.
And the mistake that I see folks making all the time is they only look at one kind of risk. Mm-hmm. And I'm always, in any change control meeting, I'm prompting people, what's the risk of us making this change? And what's the risk of us not making this change? And let's remember, risk is not bad. Risk is just, you step out on the curb, you're taking a risk. Let's understand it and come up with a good plan to mitigate that risk. So I'm right there with you, Steve. I want 100% security. I want safety to be top, but I want it all. I want us to be able to do velocity as well, because you know what? Grandpa needs his new pacemaker.
Right.
Yeah, it's interesting. So I'd like to talk a little bit about the integration of these DevOps teams and teams that are on the hardware side and working on firmware. We sort of highlighted that one side has primarily been focused on safety, the other side on speed. Now we need to safety and speed. We need to kind of bring these two and converge in some way. But I'd like to see if we can throw up that first poll and try and understand from the audience's perspective, how would you describe the DevOps interaction between your firmware and software development teams at this point? Are they separate teams? Is it something where there's some alignment that's happening, or are the two teams currently, just operating separately at this point? And I'm wondering, as folks are answering the poll at this point, let's talk about the convergence of these two. There's a clash of cultures in a sense, right? But yet at the same time, we're dealing with software. So the going in supposition here, of course, Steve, you mentioned it earlier, think about firmware as still being software. It's just software that's really hard to change. So we still go through the same life cycle. On the one hand, change is easy when we're dealing with a web app. We can deploy multiple times a day. You can't quite do that when you're dealing with firmware and hardware at this point, right? So the challenges are inherent between these two teams trying to collaborate with each other. And I'd like to dive in and start to dissect this, phase by phase. If we take a look at it, initially, we're going to construct some kind of a design. And we've got a web application design, but we've also got hardware design, which has firmware included into it. And Steve, I'm going to start with you first this time, just to get your thoughts. When you're dealing with the design aspect and you've got to consider building security in now, right? How do you go about doing that? What's the mindset of an individual that comes from a hardware firmware perspective? And then I'll flip over to you, Bob, to talk about it from the software application side.
I'll use an example from my past. I worked on a team that was developing a very secure cell phone, which is an embedded device, and at least you can think of it that way. It was Android based, and there were the firmware development team were using the same practices in terms of Agile and Scrum and all those good things as anybody doing software and applications in the team. I think the real concern there was we'll call it a chain of trust from the hardware all the way up to the application, because the customers were very concerned with that. This was a kind of device that would be used, say, by government agencies, for example. And so, we were looking at trust from all the way from power on. What is this device? Do we trust it? And we were doing measured boot. We were using, there are methods using, say, TPM chips, trusted platform module chips, that can attest to the health of the hardware and the firmware and the operating system and the software. So it really cross-connected all these different teams in that way. I think that the team had different levels of expertise, say closer to the hardware versus closer to UX, but a lot of the same techniques. Maybe that's not the best example of some of the challenges you face. I think where things can get really challenging is when different components are provided by different parties. So if it could be the chips, it could be a board, it could be some of the firmware drivers for chips. Sometimes those are very proprietary. And even as a firmware developer, you may not have access to all the nitty-gritty details of how this particular radio modem works, or camera, or what have you. So there's sort of artificial boundaries, if you will, of knowledge that can interfere with the smooth flow of information. So just to start.
Yeah, interesting. So, Bob, I mean, having different suppliers, if we take a look at the software space, I mean, open source software, this is all over the place, right? Talk a little bit about when we're dealing with agility on the software side, and as we're moving forward, but really focused on the design aspect of this, what are the security implications from that standpoint, and how do you see the convergence now? Steve talked about the challenge with different suppliers. We're trying to build trust from the hardware all the way up to the application space. What do we do in this other space here to try and accommodate this need?
So Steve, there were so many good points in there. I wish I could unpack a few of them. You remind me of a time when I did a configuration management assessment in a medical supply organization, and they were doing lasers that were used for surgery, and the firmware on the device was updated, and this was a few years ago, was updated using a telephone connection, and medical personnel would connect the phone to the modem, and the software would get downloaded to the device. And typically the hospital personnel would take 20 minutes and let the firmware download, and they figured, it's probably done now, I'll hang up. And the software was not downloaded, and the manufacturer had not built in a method for doing a physical configuration audit to see what rev of the firmware was running on the device. Now, fortunately, the device was in a fail-safe mode, so I'm not aware of any catastrophic incidents that occurred. But the fact is, they couldn't guarantee you the latest firmware was running on this laser surgical device. Serious problem. So I think, Altez, to your point, you want to design your systems to be verifiable. You want to design them to be auditable, to be deployment friendly. We have to start thinking more. And Altez, you were in the meetings with me when we designed the standard, the industry standard, the IEEE standard for DevOps. Mm-hmm. We kept saying continuous testing, continuous security, left shift, thinking of these things up front so you can design the system so that it can be deployable, the deployment can be verifiable, and the systems are highly secure. So if they're tampered with, you automatically know that they're tampered with, and the baseline can self-heal. We know how to do this. We absolutely know how to do this. But many manufacturers are not yet ready to take a DevOps approach where they consider the different perspectives of all of the smart people. When I'm doing an assessment, I almost always find the right answers are in the organization. And a lot of what I'm doing is taking the smart ideas from Tom and the smart ideas from Sally, two different engineers, and helping them talk to each other and funneling that information up to the CEO or the CTO so we can bring about real change. So this is a true DevOps challenge. And I think that it's an exciting time for us because we can apply these principles to help these organizations meet this critical need.
Right. And we've got help. It's not like we have to do this from scratch, right? We've got NIST, or we've got the P2675 standard, which talks about some of the things that need to be done. We've got on the hardware side 62443, for example. So there are things that can be put in place where, as we are designing our systems, we can measure against these. What I'm looking for is are there a set of control points that can ensure the synchronization of what's happening on the hardware and on the firmware side with what's happening as well on the DevOps and application side. So we're not sort of diverging, but we're trying to help. Help to bring the synchronization between the two, right? So even when we're designing this stuff, that there could be some challenges around that. Steve, just probing a little deeper on this, sometimes it's not possible to go in there and work with hardware from an agile standpoint. So we're starting to hear about, these concepts of digital twins and hardware virtualization that give us the ability to keep, lockstep with what's happening on the software side, on the stack there. Can you talk a little bit about that? I mean, does that work? Is that a good response to achieve agility? Do you have any thoughts on that?
So you're really talking about like hardware emulation or simulation?
Yeah, exactly.
I think a lot of times you can get away with that. It depends on how unique the hardware and software is. If the firmware is something relatively easy to model, or it's a very kind of standard, let's say it's a ARM chip, and you're developing firmware for ARM, you can do a lot in an emulator or a simulator that will translate with a fairly high degree of confidence to actual hardware, and that allows you to be higher velocity on the firmware development. So I don't know if that answers your question. I think, one of the issues I touched on it earlier, though, is you often don't have your team doing the entire sort of soup to nuts life cycle of the device. You can design the product to, you can use secure design and development practices, but you also have to think about the operational aspects of it as well. Mm-hmm. Say you do if you fail in an update of an application, you reload it. If you fail in an update of firmware, like Bob was talking to, you may get a brick. If you're lucky, that's all you get in the case of the medical devices. So, using good design principles, like Bob was saying, about basically what I would think of as configuration and integrity checking are really important. But the other aspect is the operational model. The people who develop devices often I would say frequently, are not the ones who are operating them. In IoT space, it may be a consumer, or it could be some sort of controller used in, say, an oil refinery or something like that. So there are a whole bunch of other concerns about the whole supply chain and the operational, what trusts what in that space. And I actually think this is a particularly interesting area because what I see happening in this space is typically a supplier of devices of whatever type has their own sort of, we'll call it, authentication and authorization types of operational models. And as people want to use multiple devices in different spaces, how do you manage all these devices and trust them and or not trust them, as the case may be? Mm-hmm. That could, again, medical, industrial, consumer, it's the same problem everywhere.
Yeah, interesting. So I'm not sure, can we just kind of relay out what were the results of the poll that we'd put out there? It'd be interesting to see for this particular audience kind of what the results were. So I'm not sure if we can share that information or even just mention it. Oops. Are we able to do that?
Polls.
Okay.
Oh, let me check on that. I don't have that information here, but I'll check with our team.
Okay, thank you. It'd be interesting to kind of share that information as well. So let's move on and let's. Sorry.
So Steve, if you click the polls button at the top, and then the closed.
Okay.
So, Steve, I think you really pointed out. Now you have the results. You want to read them, Oltez?
Sorry, I'm not seeing the polls. I apologize.
83%. We have some alignment between the two teams.
Got it. Okay, so let's talk about that. Go ahead, Bob.
So I think, Steve, you really had your finger on the pulse right there. It's our job to get these smart people to work together and to talk to each other and share their knowledge. And that is the whole point of the thought leadership in 2009 that came out of the conferences around DevOps. We've got different folks with different perspectives, and they're all really smart people, but they work in silos. We can't change the regulatory compliance, so those silos are here to stay, and that's a good thing. I'm not against them. We have to create high-performance cross-functional teams where they communicate and collaborate more effectively. I said to some of the engineers that I talked to at that medical company, why don't you send some of your engineers to the hospital floor and see what the hospital personnel are doing? Do you get a sense of what their life is like? And the number one question, Oltez, that I always start off with, can you prove to me that you've got the right code running in production? Production might be grandpa's pacemaker. It might be the firmware on a GPS-driven train. And can you prove to me that the software is the correct version, that it has not been tampered with? Can you flash it back again if you need to? Mm-hmm. Can you also interrogate the hardware and make sure it's operating as it should? That's called the physical configuration audit. And if it does the right thing, it's the functional configuration audit. Basic CM terminology. So Steve, kind of my response back is this is exactly what we're talking about in DevOps. This is what we do every day. It's so much fun because we get all different smart people with very different perspectives, and we get them to communicate and collaborate more effectively. The most important thing I do is I get people to share a screen and teach each other. Mm-hmm. As you guys were talking, I wrote down KT for knowledge transfer. I'm always trying to get people, I'm trying to create a learning organization to get people to share their best practices. And that's when you're able to accelerate velocity, but you've got the security guys weighing in, you've got the systems guys weighing in, you've got your end users helping you to set priorities. That's when you have a true DevOps culture where you can have the right balance between security, reliability, and velocity.
Right. Yeah. And I even see the term DevSecOps to try to emphasize that, right? I'm not sure there's a formal or an agreed upon definition of it, but I think of it as, DevOps, you're really responsible for, as a developer, doing developerish things, but you also need to have an eye towards how to operate it. And security also needs to be in that mindset, as you were saying. And I don't know whether the formal name helps, but certainly there's so many different aspects to security. It's very difficult for one person to be aware of them all. And ultimately, I think that from a responsibility perspective, it spans the entire team.
Yeah, so you've got security in there, you've got testing in there, you've got quality in there. How about the end user? I've had plenty of times when an end user has come to me and said, Bob, I know the software isn't fully tested, but it's broken. You push out the changes because it might fix some things, and it's already broken. It's not going to be more broken. So stop being such a stickler for testing when we might be able to get some things fixed. I had a situation not too long ago where the software was broken. We hadn't thoroughly tested it, but the impact of pushing out these fixes could alleviate a very serious health concern. And I don't want to get more specific than that, but the risk of not making the change was greater than the risk of making the change. This is the DevOps mindset. Can I look at the whole system? Can I include different perspectives and make a smart decision all the way around?
Yeah. So you're essentially moving quickly, right? You are getting things out. You are helping to move things forward, but you're doing it with the lens of risk. What is the high priority risk, and how do we lower that risk? This is ultimately what we're trying to do here.
What's my plan B? Risk is not bad. Risk is great.
Or the opportunity that risk might represent. Yes, you're right. Right, something like that. So let's so we talked a little bit about the design side of things. We talked about a few, some of the controls that we can kind of put in there. If we go from the design, now we're in the coding stages. In typical web application development, coding is, we've got several different frameworks. A new one seems to be emerging every day. We kind of integrate these together, and it's really about trying to put this together in a way that is focused largely, or has been largely focused traditionally, on accelerating the developer's ability, just their productivity. Whereas I believe if you take a look now on the hardware firmware side, there's a slightly different model there because we've got constraints, memory constraints, and we've got CPU constraints and stuff like that. So, how do we bring these two now together? How do you get, the two teams talking to each other? We want cross functionality. We want learning to be happening. We want knowledge transfer to be happening. But what do we do? Because we could get vulnerabilities on the higher layer, which is the web application software, for example, which could eventually make its way down into the firmware if we're not careful. And it could go the other way as well. We could get people trying to do stuff with the firmware that eventually impacts the application. So we've got to think about security holistically. But how do we manage this? Two different set of constraints, two different mindsets. Thoughts?
So one of the things that I advocate for is that you really have to take a systems viewpoint. And it's very difficult to get everybody to look at it that way, which, because you're talking about, all the way from application to kernel to firmware to hardware. And while it's in the ideal world, you don't want to have any stovepipes, and you should always be striving to that in terms of up training the people and the skill sets in different places. I do think there is sort of an overarching responsibility of, say, we'll call the role like a systems architect or a systems designer, that kind of helps tie all that together and ask some of the questions that somebody working on their piece of it may miss. That's an aspect that sometimes I feel like gets neglected. Again, on the one side, just because people don't have the skills to think about integration challenges, and the other side is, you want to be training people up to learn about those things over time.
Steve, I think you're spot on. And one of the areas where I've seen this is you could have hardware engineers who are identifying a problem, and they're starting to think about, well, how do I refabricate this? And if they communicate with the guys writing the firmware, they may have a faster way in which they can slow down a loop and help alleviate whatever heating problem or friction problem is occurring. It's not a perfect solution, but now we take the urgency off of it. Now, the hardware guys are focused on their silo, and they're not aware of the capabilities that the firmware guys can bring to the table. Now, if I get them in a conversation together and I help those two silos communicate and collaborate more effectively, then I may have a situation where the firmware guys say, hey, we can help you out. Maybe it's not the perfect solution, but we can make things a little better, and that buys you some time to fix the problem, in a better way with the next rev of the hardware. So I really think this DevOps mindset is something that we need to really focus on. And a lot of it is teaching folks to share knowledge, not to just keep it close to the chest, but understand there may be good ideas from other folks in the organization. And Steve, I think one of the challenges that I personally have, I love thinking that I'm a smart guy, right? I'm an engineer. I love this stuff. I dream in code, but it's sometimes hard for me to say, hey, maybe somebody else knows more than I do. And, how can I get people to be more effectively share their knowledge and work together as that high performance cross-functional team? That's the essence of DevOps, and where I think we really can bring them together.
In my mind, I kind of classify that as agile or lean culture, and instilling that culture into your team. And there's a lot of different agile coaching types of techniques that'll do that. It'll never be perfect, but it's something to keep improving over time. That ability to share retrospectives are so critical to that. For example, that they're a non-threatening environment. There's no bad dog. There's just mistakes that were made, and we got to learn from them so we don't do them again. What was that quote I saw recently? It's an old one about we don't make perfect product. We just fail faster than anybody else.
So I think you're bringing up a really good point there. Altez, you want to talk about the poll that just came up?
Just folks, while you're in here, if you would like to know more about what SD Elements can do, this is for folks that want to reach out and want to have a conversation with Security Compass. Please feel free to go ahead and do that. In the meantime, we can continue our conversation. Feel free, Bob. You're in the middle of a thought here.
Yeah, so what I was going to say is I've had quite a few experiences where I've tried to introduce lean and agile principles to hardware engineers. And it is often not something that they've really been accustomed to. It tends to be more in the software world. So one of the principles that I've often talked to folks about is the Poppendieks coined the phrase, last responsible moment. And that one really makes sense. How do I postpone my final decision till I have enough information in from my POCs and my testing to make the right decision, as opposed to a classic waterfall method where I'm making all the decisions up front, perhaps before I have enough information. I'm not opponent. I am not an agile only kind of guy. I believe iterative waterfall works just fine in many organizations, but teaching these principles so that people think of things differently, share their knowledge, and make the right decision from a systems point of view, Steve, as you pointed out, I think is really the key thing we need to do.
Yeah, one thing I advocate on the POC, the proof of concept side of things, is to think about them as ways to buy down risk. You're not just proving out a concept. I mean, I think you can do that on a whiteboard oftentimes. It's how do I reduce the risk of making the right decision?
Yeah.
I think we're saying the same thing in different ways. But.
Yeah. It'll be interesting. Go ahead, Bob.
But that means that you teach people what risk means. I've had engineers that have said to me, "Oh, there's no risk. We tested it. We thought it through. There's no risk." And I'm like, "There's always risk. Risk is not bad. Let's understand the risk. Let's understand the risk on both sides." So a lot of it is teaching folks how to use risk as a tool. Risk can be your friend if you understand it well and you use it the right way. But I think, again, that's a culture shift, Steve. I think a lot of folks are not used to looking at risk that way. You go to a trader on Wall Street, he knows what risk is, and he makes millions that way.
Right.
Not but engineers, risk is bad.
Right.
We've got a poll on this. Let's throw up the other poll that we've got on the risk one, which is I think second on our list here. If we can put that up, how do you currently manage ongoing product security risk assessments? This will be really interesting to see what kind of response we get on this, because I think several times in our conversation today we've started to talk about this idea of risk assessments and how do we do this on an ongoing basis. Now, when we're dealing with DevOps and web apps and things like that, we do this on a continuous basis. How do we bring that speed and velocity while still maintaining security at the same time with the firmware development becomes a key thing. So we're not shipping out products that have these sort of reactive security incidents that exactly right, and so far in the response that came back is we use a common risk assessment between these, as well as the software side.
Altaz, you're chopping in and out, just FYI.
Okay.
Your computer got busy doing something else.
Yeah, unfortunately, Altaz, we lost a little bit of your sentence.
Sorry, can you hear me okay now?
Yeah.
Yes.
Yeah, great. So I just wanted, so we've got this, 100% of the folks that are, participated in the survey, in the poll here, said that they use a common set of, like a common risk assessment between the two, the hardware side and as well higher up in the stack on the software side as well. Comments on this? Is this commonly, from your
if it's valid, that's
your experience,
great.
Is this typically what's done? There's a convergence?
I'm a little suspicious. I think a lot of times folks are afraid of risk, and it may be common because it's not thorough enough. And I'd wonder how if you really could use the same framework for both. So I'd want it to be valid and verifiable, and I'd want it to be meaningful. And I'm just a little bit afraid because I find some organizations, they have a culture of being afraid of risk. So they kind of kick the can down the road and they don't really dive into it. A lot of what I do in my work is I help teams embrace risk and use it to their advantage. So I'm a little suspicious to whether or not those organizations have really dived into risk and understand it fully. Steve, what do you think?
Well, I think the security aspect, if we think of like a DevSecOps, is it requires some training, and that oftentimes you won't see in a typical software developer. And so that's an aspect of this too. If you're going to be doing risk assessment in teams, then you need the expertise and the training to think about things like risk assessments, threat trees, fault modes, measuring consequence versus risk, and so on. Those aren't things that, it's a skill set you have to acquire actively, and some of it comes with experience, but training can really help. And I don't know, for the people answering the poll where they're at on that journey. But it is an important part of the journey when you're worried about product integrity and functional integrity of, say, a medical device.
Training is the hill to die on. There's nothing more important, and it's got to be more than just a course that you.
So
it's got to be a culture.
Yeah,
it's got to be a shift in the way you think of things, where it's cool for me to teach you what I know, and I want to learn what you know. Where we're always teaching each other, and we make that part of the corporate culture every day.
Right, and you know, the more senior to junior mentoring aspects are really important as well for this. I don't think I appreciated them as much as a junior engineer, although I definitely appreciated when people were helping me understand something. But it takes, I find as a senior engineer, it takes some forethought to figure out how best to transfer some of the experience that you have to other people. Don't hold it close to your chest and, you know, it's job security, only I understand this. That's not the goal here.
Yeah, and you know, I'm certainly the senior engineer in many places, at least in terms of number of years having done this stuff. And I find what's really fun is a lot of times I learn from the junior folks, and I got to, you know, continually resharpen my pencil and really come back and constantly learn what I'm doing. So I think, again, it's creating that culture where we can share information, share knowledge, and really make that part of the way we do things on a daily basis.
And
I do want to mention
everything is just because the tooling and techniques are changing all the time, right? It's not a static environment.
And a lot of young people come in with fresh new ideas that are cool, and we really want to include them. Hey,
there's nothing more valuable than somebody who doesn't know it can't be done.
Yeah. So Oltez is joining us again. Let me mention, while I have a minute, I'll filibuster for just a second while he rejoins us. We are starting up a new working group at the IEEE to revise the 828 configuration management standard. And all the things that we've talked about today in this discussion, particularly about thinking about an agile, flexible approach to the BOM, to the bill of materials. How do we handle constantly changing firmware on a hardware device? How do we embrace agile principles, velocity, lean, DevOps perspectives and knowledge transfer? We're going to be focusing a lot on that new standard for 828. So folks who are interested in configuration management, if you eat, sleep, and drink CM, give me a call. We'll have some beers, and we'll get you involved with helping to create the next version of the 828 IEEE standard.
I'm curious, Bob, whether one interesting aspect that a lot of times people don't think about is configuration history. You know, particularly when you're talking about security, you often discover after the fact that there is a compromise, say, in some library that you're using, either at firmware or software level. And you want to know, was I vulnerable when this first became known, not when it was finally published? Is that part of the manifesto, if you will, of that working group, the history aspect?
It is. And, you know, in CM, we call it having a baseline and being able to compare baselines and use baselines effectively. That is really, really important. So, you know, it's important for us to look at history. You know, it's often been said, you don't know where you're going unless you know where you've been.
Yes.
So the history of those baselines is very important. I find organizations often can't tell me what is supposed to be in production. So those baselines are really key, because that allows us to really revert back to a known state.
Right. And the other aspect that sometimes people miss, depending on the product or the operational space, version skew, when devices have to operate together, can often be an issue. You may upgrade some and not others. And so there's a whole regimen of risk and understanding around which different versions can interoperate together.
I think that's true. And I'm going to ask Tom Field if he can come back in and talk to us for a few minutes.
Yeah, great. Thanks, Bob. Steve, appreciate that. Naltaz has got knocked off and having some trouble reconnecting, so we'll take it from here. If my team can get that third poll back up there again, we'll display that. Meanwhile, How about, Bob, you and Steve each take a couple minutes here just to wrap up with some closing thoughts. What do you want our audience to take away from this discussion today? Bob?
Well, I think we're just at a really exciting time for the convergence of really best practices between CM and DevOps in both the hardware and software industry. I think we're moving away from kind of a traditional mindset to a more exciting mindset. And I'm 100% focused on security and reliability. I don't believe that any system should be susceptible to be attacked without having some way to automatically determine that it's been tampered with and then revert back to a known state. In other words, yeah, the system might get tampered with, but I can revert it back to a known state. I can rebuild infrastructure. I can set us back. I can detect if things are being tampered with. We have cool capabilities right now. So I think that we're at a real point where there's a lot of excitement around what we're doing. What do you think, Steve?
Well, I think I have a similar viewpoint with maybe a little different emphasis, which is that the security aspect of so much of our devices where they contain firmware, particularly consumer space, but also medical and whatever, manufacturing. Security has really been a backseat partner for a long time, and we've seen the effects of that. We see them in the news far too often. And so I think, the takeaway I'd like to see is that people really do integrate security into the full life cycle of the software, starting from design to implementation, all the way out to deployment and operation. And even retiring is an important part of life cycle. When you get rid of a device, what sensitive data is still on it? How do you get rid of that? So there's a whole life cycle there that I think, at least traditionally, historically, security has been a bit of a backseat, and we need to change that. Oops.
Well said. Well, Steve, appreciate your comments today. Bob, we appreciate your insight as well. Thanks so much for joining us today.
You're welcome.
And to our attendees, if you have questions that we've not answered, we will get responses back to you via email. I do appreciate you being here for this session today. I hope that you've taken away some valuable new insight on this whole topic of managing risk where hardware and DevOps converge. I want to thank our guests and our sponsor, and I do look forward to seeing you again at our next session. Until then, for Information Security Media Group, I'm Tom Field. Thank you so much for your time and attention today.